Here we go.
Oh, what did we do yesterday?
Yesterday, we turned in the Chapter 6 practice test. Okay, so if you've got yours, come up and sit it on my desk so it's not getting mixed in with these review papers. Today, the Chapter 6 review is due. We just turned that in. And I'm going to work on getting your guys' tests graded. Probably should be in the grade book by Friday, but I don't know if you'll get it back until next week. Now, we do have a 3-day weekend this weekend, so with President's Day. President's Day.
Let's go.
So probably get it back on Tuesday would be my guess. All right. This section is not representative of how this chapter is going to go. They start you off with an easy section that you could do if you were in 4th grade math. Okay? And then as the sections keep going deeper and deeper into this chapter, it gets progressively harder and harder. Okay? And I really mean that, okay? Because the different transformations that we're going to look at, they get more complex as we go. And there's more work and more critical thinking. You have to think about, how it's going to move in the coordinate plane. Before we start this, remember that after the test yesterday, we started the chapter 2 opener. So if you have not finished it, it's due tomorrow. It's not due today. It does not need any work paper, but I just don't want you to forget about it just because we didn't dedicate a section of notes to it. Okay? It was asking you to take points and reflect them. And that's actually what Friday's lesson is over. Okay? Tomorrow's Thursday.
What is he saying?
So this section is titled Congruent Figures. We're going to look at congruent figures, and then we're going to look at 3 different types of congruent transformations. Then we're going to look at similar figures and look at one type of a similar transformation. Riley, for this section, probably not. Okay, not for this one. Congruent figures have the same shape and the same size. Same shape, same size. That means that everything about the shapes is the same. The same area, the same perimeter, everything. To be congruent is another way of saying equal. The reason they don't say equal is because equal is a term used in algebra, and congruent is a term used in geometry. And back when these ancient cultures like the ancient Greeks and Romans were doing this stuff, you didn't really use those words interchangeably. You wouldn't say that 2 buildings were equal. You wouldn't say that 2 circles were equal. You would say that they're congruent, which meant they had the same shape and all the same features. Equal was only a term they used when you're talking about 2 numbers, but it really means the same thing, okay? So everything about the shapes is the same. These 2 triangles are congruent. They don't have to be facing the same direction, but to be congruent means, again, same size and same shape. And what that actually means is all the angles match up. The matching angles are equal and the matching sides are equal or congruent. You can't really tell from the way that they rotated this triangle, but this angle matches up with this angle. When angles match up like that, it's called corresponding. They correspond. So those 2 corresponding angles are equal. These 2 corresponding angles are equal. And then the 3rd corresponding angle is equal. The side lengths between those angles will also equal. So this side corresponds to this side, and this side corresponds to this side. Okay? And then the 2 bottom sides correspond to each other. Those sides will be equal. Everything is the same. If an angle changes, it changes the shape. You can't do that and have 2 corresponding shapes. Okay, so if I'm looking at a triangle, for example, that is a right triangle, and then I say, all right, I'm going to widen it out a little bit. Even if the areas were the exact same, they're not congruent because the angles don't match up and there's no corresponding angles that are equal. So you've changed the shape of it, no longer congruent. Okay, so everything about the shape has to be the same. What's different about those two? Dylan? Yeah, they didn't change the angles, actually. The angles are all equal. They changed the side lengths, which kept it the same shape because they didn't change the angles, but because they changed the side lengths, it shrunk it down. Okay, we have a name for this. That's called a dilation, and we'll talk about it next week. Okay, so not congruent. Similar, not congruent. Riley?
Will we have anything with this lesson with different shapes?
There could be different shapes, and if they were, you would say not congruent. That's basically as far as this lesson goes with that. All right, so in congruent, here's basically me repeating the same thing. I should have looked ahead. In congruent figures, corresponding sides and corresponding angles are equal. Here's a better picture of the triangles that I was trying to draw up there. Corresponding means matching. Okay, so in congruent figures, even in similar figures we'll talk about next week, there's always sides and angles that match. So side BC corresponds with the color-coded blue one on the other side, side EF. And angle A corresponds with angle D over on this side. Everything matches up and they're equal. So in this example, it says the figures are congruent. Name the corresponding angles and corresponding sides. This little marker right there is an angle symbol. Okay, when you guys take geometry your sophomore year, you're in advance. When you take it your sophomore year, you'll be using the angle symbol a lot, and then you'll be using like line segment bars, rays, lines. There's a lot of different abbreviations in geometry they use so you don't have to write everything out. So instead of writing out angle A, we can use a little angle symbol. Sometimes people put a little bar in it like that. Means the same thing. It's a little angle symbol. So on the bottom trapezoid, which angle corresponds with angle A? Madison Davis, what do you think? Angle W. Okay. Good. What about angle B, Caroline?
Angle X.
Good. And angle C, Ashton?
Y.
Angle Y, okay. And then angle D, Olivia?
Angle Z.
All right. Now, let's look at the side lengths. This little bar right here means segment. Segments are used when you have a shape like this. Segments stop on both sides. A line continues on forever. A ray continues on in one direction, but segments stop. So you usually use these when we're talking about sides of a shape. AJ, you have a question or an answer? Okay. AJ, what side corresponds with AB on the bottom trapezoid? WX. Okay. Now, we'll talk about this here in a moment when we talk about congruent statements. If AJ would have said XW, he'd been talking about the same side that corresponds, but it would be counted wrong because in the order in which he said it. Because if I'm going to write it, I have to basically do the same thing out of the angles. If they said A to B, I have to do WX because W matched with the A and X matched with the B. Okay, so even though WXW is the same segment, he would count it wrong because it wasn't worded in the correct order of matching with A first, then matching with B. Okay, what about segment BC, Max? XY. Again, YX would be the same side, but not the correct order. Jocelyn, what about CD?
YZ.
Excellent. Yep, and put these little segment bars over it, so we're not talking about not just two angles, but a side that those two angles made up. Riley, what about the last one?
Segment ZW.
Nice. Segment ZW. I'm not sure why I made that one so small.
Why do the equal signs look like that?
Great question. Why do the equal signs look like this? These are called congruent symbols. Okay, so a congruent symbol looks like an equal sign with a little squiggly over it. And it shows that the two angles are equal or the two sides are equal, because that's what congruent means. So in geometry, this is the symbol we use for equals instead of an actual equal sign. Okay? Yep, just means congruent to. So writing a congruent statement, I just told you that the order matters. Here we have two triangles, and I'm supposed to write a congruent statement for these triangles. So, because geometry uses so many abbreviations, instead of writing out the word triangle, I can actually use a triangle symbol. Doesn't even have to look like the triangle that I have. This is just a basic triangle. It doesn't have to look like this one here. But that little symbol means triangle. And now instead of talking about three angles, I know I'm talking about an actual shape. So how would I label the top triangle, Devin?
Triangle ABC.
ABC, okay. Is congruent to.
Yeah.
So I would use a congruent symbol, which we just explained is an equal sign, a little squiggly above it. Now, because Devin chose to say the top triangle was triangle ABC, he kind of didn't really give us a choice of how we can say the bottom triangle. We have to match up A with A with its angle, B with its angle, and C with its angle. So Elise, if Devin said ABC, what are the three angles in the order that match up with ABC on the bottom triangle? D, E, F. Good. So triangle D, E, F. That's called a congruent statement. Riley?
So, circles, I know they don't put angles, so you wouldn't really do it this way, but
Mhm.
is there a certain way you could write it as congruent to another circle? Like just number the circle or something?
Yeah, that's a good question. I don't think I've even seen that problem. Well, because there's only one dimension on a circle, like radius or diameter, you could say that if the radii are the same, then the circles would be the same. Have to be. Or if the diameters were the same, that the circles would be the same. Yeah, but I don't know if we have a symbol for like circle A equals circle B or something like that. It's weird. That's a good question. I don't think we do a whole lot of that. Caleb?
Could Devin say BAC
He sure could.
and then EBF?
He sure could. Yep. You can list the top triangle any way you want. So CBA is an option.
Or CAB?
CAB, CAB is an option. BCA or CAB is an option, as long as whatever order, if Devin says BAC, we need to go EBF then when we label the other one. Okay? Now, when we look at other shapes like this one here, there is actually a rule. You don't have to go, once you pick a point, you don't have to go clockwise or counterclockwise. You can decide which way you want to go, but you can't skip around. If I'm going to write a congruent statement for this pentagon, how many sides does the pentagon have? 5. If I'm going to write a congruent statement for this pentagon, I can't say that this is pentagon J, M, N, K, L. I can't do that. I can't jump around and do whatever I did. Okay. Now I can choose to start with the letter J and then go clockwise, J, K, L, M, N. I can choose to go counterclockwise, J, N, M, L, K, but I can't jump around. I don't even have to start with J. I could start with L and do the same thing, but I can't jump around, because when you make one of these congruent statements, whoever's reading that statement would assume that the segments that the way you're listing the angles, those segments connect to each other in that same fashion. Riley?
So if you're doing J, K, L, M, N, would you have to go back to J because it's a point? And
Nope. You'd only list, I know what you're saying, like, because you're going all the way around. Okay. We didn't do that with the triangle though. We didn't do A, B, C, A. Right. You only have to list them. So it's assumed that whatever one you stop at, whatever one you start at and whatever one you stop at, that those would connect. Okay, it's a good question. Dylan?
So do the letters always have to be in alphabetical order?
No, but I typically do it. But even if one of them's alphabetical, that doesn't mean the other one's going to line up alphabetically.
That's
Okay.
crazy. That's literally what I was about to say.
Well, we could do it alphabetically. We could start with J, and we could say, now there isn't an abbreviate or a symbol for Pentagon, but I can definitely abbreviate it. Just do PENT.
You
Okay.
need to change your calendar. Because it's not December.
Hmm?
Your calendar's in December.
Oh, are we not in December anymore? Tells you how often I look at it. Yeah, so we'll do Pentagon JKLMN. By the way, these are all capital letters. If you try putting a lowercase letter in Big Ideas, it'll say it's wrong because when you list capital letters or segments, when you list angles and segments, we always use capitalized letters. Not sure why, this is what we do. Then we're going to say it's congruent to, because it is congruent to, but I want you to notice something. They've, looks like reflected this shape. Okay, so what do you think, Ashton?
SRQVT.
SRQVT.
Yes.
I would agree. Because it's obvious to me that if I start at J, J to K is a longer line segment than what J to N was. So if I'm starting at S, which is where, which one J corresponds with, I have to go S to T. I'm sorry, you said S to R. I have to do S to R, which is that same longer segment. And I know that M and V both match up since they're right angles, and the only ones that are right angles, right? So I'm going to say Pentagon SRQVT. Okay. And so here's what that means. Without looking at the shape anymore, I know that K matches up with R. Those two angles will be corresponding and equal. I know that M matches up with V. Those two angles are corresponding and therefore equal. Okay. I know that segment LM matches up with segment QV. I know that segment JN matches up with ST. As Riley was just mentioning, the last letter you give is going to then connect to the first letter you give to complete the shape. I know that from this, there is no JM line segment. That doesn't exist. That'd be cutting through the shape. And there is no SQ line segment. That'd also be cutting through the shape. So I know a lot of different things. Now, you might be thinking, why would anyone take the time to do this? When they start changing the size of the shape, when they start not only rotating it and reflecting it, but then also changing the size, it becomes very important that our congruence, actually, in that case, it'd be a similarity statement, that those match up. Because then that tells us which two sides we need to include in our proportion that we would write to figure out how long the sides are. Because they're proportional. We'll talk about that later. Claire?
So this isn't really this is kind of like a macro question, but to figure out if they were just a tad bit off, would you have to use the distance formula on every single different line to find out if one was just a little bit off?
Could, but
Or is
you
there an
won't
easier
you
way?
won't have to do it here. A lot of times they'll just tell you what the distances are. Like on some of the homework problems in this homework, I think they told you what some of the distances are, and then they said they didn't have one in the other shape, and they said, but it corresponds to this one, and you look in the other shape, and they told you that one's 16, so you know that one's going to be 16. That's pretty much what they do. That's why this homework is going to be very easy and not very representative of how this chapter is going to go. This chapter is going to get a little bit deeper and deeper in detail. Next example, which square is congruent to square A? Olivia?
Square C.
You got it. They've rotated it, but they didn't change its shape or size. Square B, they didn't rotate it. They didn't change its shape, but they changed the size. And so square B would not be congruent with square A. Trapezoids ABCD and JKLM are congruent. And I wrote those letters in a specific order because that's our congruent statement right there. What is the length of JM? Well, without even looking at the shape. And again, I know you can look at it because they didn't rotate it, they didn't reflect it. They're literally the same image of each other. So you don't have to look at it. But if I didn't have that image, I can tell you that JM is going to be the exact same length as AD. Is that true? Is it AD? Does it match up with AD on the other shape? It does, because they're both the bottom sides there. Okay. So what is the length of JM going to be, Elise? 10 feet. Good. And if every single side is the same, then they're going to have the same perimeter. So the perimeter of one is going to be the same as the perimeter as the other one. Caitlin, what's our perimeter here? Oh, what were you going to ask?
Oh, well,
Okay. Riley, were you going to answer that one? What's our perimeter for the shape?
32 feet.
Okay. Think 6 and 10 make 16. 8 and 8 make 16. 16 times 2 is 32. Okay. What were you going to say, Caitlin?
Oh, I forgot.
Okay. And then it says which angle of JKLM corresponds to C. Without even looking at it, it's got to be L, right? How do I write it though? I just put L down? Angle L. Angle L, just like they did. Angle. What'd you say?
If you want to write it as an equal to, you have to put the wavy line.
Oh, yeah. Sure, we could do that. Congruent. You could say angle C is congruent to angle L. Because if they do correspond, we know they're the same. So they're congruent to each other. Yep. Ah, finally, you can see what I'm talking about when I say they don't all just copy and paste each other, right? This one's been rotated a little bit. So I really do need to focus in on the congruence statement here to make sure I'm matching up the right angles, the correct angles. They don't look like there are any 90-degree angles in here. The correct angles with each other. So
you were right when you said right angles.
Technically, but I didn't mean 90 degrees. So I just want to make sure I clarify that. I want to find out what X is. So when I look at X, I find it here. X is actually part of the side RP. So I go to my congruent statement. I look for RP. It's right there. RP is going to correspond with what side on the other shape? AJ? VW. Okay. Well, technically I said RP. So I'd have to say VW. If I would have said PR, then WV. Okay. That takes care of any of the guesswork. Like I now don't have to guess which side. I know for a fact. And so WV is this side right here. Now you might have known that RP was the shortest side and it would match up with the shortest side on the other shape. Yeah, I'll give you that. But now I can be certain. So let me solve that. Nuche, if X plus 5 is equal to 12, then what's X equal to? 7. There we go. All right, let's do the next one. Now I'm looking for Y. Y is part of the side length on TW. So TW matches up with QP. So I go to QP. It's actually the bottom side over here. Didn't look like it was going to, but I guess if it's been rotated, it doesn't quite look as long as what it was if you lay it on bottom. So because they're congruent, I know those two sides have to be equal to each other. Cooper, 6y is equal to 24. What's y equal to? 4. There we go. Finally, Z. Z is, I should use a different color. Well, I was going to, but it's already given me everything red. Z is part of angle V here. And I know angle V corresponds to angle R. So since the corresponding angles are the same, I know that 11Z is going to give me the same measurement as 132 degrees would. Okay, Devin, what's Z going to be? 12. 11 times 12. Oops, 13. 11 times 12 is 132. Yep, not much going on here. In fact, I don't even think there's a question like this one. I think I copied this from a different textbook, just because they make this section easier than what it could be, but it is very simple. So you may want to refer back to this one. You might have a question, even though it's not a homework question, because we covered it in our notes. You may end up having a question like this on your quiz, where you might have to match up a shape where it's been rotated or reflected, and not just an easy one like that. That one is from your book. It's like, they're not all that easy, but the book made it that easy for some reason. So that's it. That's the notes. So we have 17 minutes. Go ahead and start working on 2.1 if you haven't started already. And then at 2 o'clock, or actually 1:55 is when we're supposed to get out of here. But even though it says 1:55, I'm going to keep doing what I've been doing. I'm going to make sure to dismiss you guys when there's not already a line out there. Okay. So I'll just keep working. I'll check, dismiss you. We'll come back. And because today's Wednesday, we're going to read our dear books when we come back. Yes.
This homework assignment has no work paper, right?
This one does not. You're correct. Yeah. The chapter 2 opener due tomorrow, and this 2.1 homework, no work papers. But starting tomorrow, we're back to work papers. Caleb? I suppose so. Max?
Can you open up tomorrow's homework?
No, I want to go over it first. I mean, it'll open at 7:30, but I'm not going to let you work that far ahead. You can wait till tomorrow. If you have everything done, then you could start reading your book early. And if your response to me is going to be the same question or same I got from my first period class, that you just don't like reading and reading is boring.
IXL.
Well, that's true. I did post the IXLs you could work on for 15 minutes. But no, I really do want you guys reading. If you don't like reading, then you haven't found the right book yet. Okay? Saying you think reading is boring is the same as saying movies are boring. There are some that are. They're not all boring. Okay? So don't just make a broad statement that you don't like reading because you apparently just don't like the book you got. I would say, well, go with a different book. Caitlin, what's up?
So the homework for tonight does not have a work paper.
Correct. 2.1, no work paper. Chapter 2 opener, no work paper.
It's super.
Sure.
So